large log files, and you're going to be limited on your logging space. So I'll keep it here at 50 Hertz. That's fine. Automatically erase memory at 100% use. This basically is going to be loop logging, where it's going to record the latest log in your logging list if you forget to erase your logging memory out. That option is decent, so I'll go ahead and toggle that on. Everything else here should be fine, so we'll leave all the other values or parameters alone here. Let's go to individual channel options. We'll run with the defaults. Digital options will run with these defaults, and math channels we don't need to worry about right now. Let's go down here to idle speed control. Now, idle speed control is going to be part drive-by-wire, also part spark timing feedback. Now, how it works with the drive-by-wire throttle blade opening and the spark timing is going to depend on the settings you select in here. Let me explain. When we're dealing with drive-by-wire control, one of the advantages of simplifying the cranking airflow and the idle airflow. This improves the stability of the idle control and how the engine cranks, fires, and runs. It's really, really nice to drive-by-wire. So essentially, we can command the throttle blade open to pretty much whatever we want at idle conditions to bring in a certain amount of airflow to build a certain amount of engine torque output. Idle control is all about manipulating your engine's torque output. More torque, higher idle speed. Less torque, less idle speed. So you can think of the throttle blade opening as being the primary means of what your engine is going to make for engine's torque output. Now, things that can affect torque are fueling, airflow, spark timing. So airflow and spark timing are the two variables that affect our engine's torque output. So when we're talking about drive-by-wire idle control, what we'd like to see happen here, and gives the best, most consistent, repeatable idle control, is that we are going to park our throttle blade open at a certain fixed angle, and that's going to give us our base airflow, our base torque. Then we can use our spark timing, and we can vary that, either increasing or decreasing the spark timing in real time. We can do this pretty much instantaneous to drive up or down the engine's torque output to hit the desired idle speed that we're requesting within our idle control parameters. This is a closed loop system, and we can be very specific of how we apply this. We have two options. One, we can allow the throttle angle to move around and the spark timing to move around, and that can create decent idle for some engines. Most engines that are pretty extreme in modification with big cams, that spells an absolute disaster for idle control. So what I'm going to do here is choose parameters very specific so that I'm calling out a fixed throttle angle for my base airflow, then allowing the spark timings of feedback dynamically, very quickly, to influence the engine's torque output to hit the desired idle speed. So hopefully this is all making sense. All right, let's go in here and take a look at our settings. So what we'll find here is we have our idle speed control and idle reaction level. Let's leave that 1 right now. Once the engine actually starts to run, we can change this. This is going to be how quickly the spark timing adjustment is going to happen in here. Now, we have our position on idle. There's an automatic or a fixed. Automatic varies the throttle angle within the closed loop control to try to hit the desired idle speed. You have two moving targets at that point. Throttle angles moving and ignition timing. Definitely not ideal, in my opinion. The other option is fixed. Fixed allows the option here, if we click on here, it allows us to actually call out the throttle blade opening in our table here for idle control. This is definitely the most ideal option. So fixed is what I'm going to choose, allowing us to have that fixed throttle blade, fixed airflow, and allowing the spark timing as the means for our primary adjustment in our engine's torque. Then we have our cold idle position reference and a hot idle position reference. This is going to call out what we want our throttle angle to go to under cranking conditions for a cold or a warm engine. I'm going to call out 5 and 4 just to get started with. We can always tweak and adjust this. This is our cranking airflow. So just as you would crank over your engine, let's say mechanical throttle body, you're trying to fire off your engine, you get a little bit of throttle for it to fire off. We can do that virtually now, and that's what this represents. How much that throttle plate's going to tip open to allow the airflow to come in, to allow the engine to crank and fire off. All right, now we have our idle timing limits. This is that dynamic feedback that I was just mentioning for the idle control. This is the range it's allowed to adjust the idle spark in, to adjust your dynamic torque output. So the torque is going to allow you to hit the desired idle speed. What this is going to do is take a look at what we command here in our target RPM table, look at where the engine's actually idling at. If we're above or below, it'll adjust the spark timing accordingly. And this is the range that it can adjust in. -5 is our floor, 25 is our ceiling. So it can go anywhere between that. That's fine, we'll leave those default values there. Now, enable timing return ramp for idle by timing. We want to have this turned on. This allows you to transition from your idle spark feedback and idle control to the normal main spark timing tables and back again in a nice smooth controlled manner. Otherwise, you might have an abrupt change going from your idle spark control to your main spark timing table values. So we want to have that on. There are some options here for air conditioning load compensation or thermofan load compensation. If the fans turn on and it draws down the engine from a draw on the alternator or the AC clutch assembly, the AC compressor kicking on, it can draw frictional drag on the engine, torque loss. We can compensate in here with our throttle blade opening. We're not going to do anything yet, but we could do that if we'd like. Let's go here and take a look. We have our target idle RPM. This is where we command where we want the engine to idle at. When the engine's cold here, 50 degrees Celsius and below, I'll call out 1400 RPM for my desired idle speed. Cold engine, we want the engine to warm up quick. 1400 RPM stabilizes the idle output and allows the engine to warm up quicker. Now, when we're warm, the engine's warm, I'm going to say 140 degrees and warmer. I'm going to command then 900 RPM idle speed out of my idle from 140 degrees and warmer. Between 50 and 140, I'll go here and I'll just click H, and that's going to horizontally interpolate, which looks like 1100 already is going to give that value that we should go in here. So as the engine's warming up, we're decreasing our engine's idle speed. This is mimicking how the factory ECU would work. This should be good. If we go here, then we also have our idle actuator position. This is taking a look at what we have here for the coolant temperature and then the desired throttle angle. This is calling out what your throttle blade will actually open to between 0 and 100%. Now, depending on your throttle body size, the value we place in here is always going to be different. What I'm going to say here is between, let's say 50 degrees Celsius. I want the idle to be at 1400. We don't know what's going to be the throttle blade opening to get us to 1400. I'm going to guess 8%. It's always better to go a little bit higher when the engine fires off. It'll idle a little bit higher, and we can always adjust this quick. When I'm at 104 degrees, I'll call out something like maybe 5% throttle blade opening. And on my warm speeds here, or my warmer temperatures, I should say, I'm going to go in and command something like maybe 3% throttle. Again, this may be too high, but we'll figure out what it needs to be. Now, the larger your throttle body, the higher throttle angle value needs to be. The smaller your throttle body, the larger the value would be. Essentially, think of your throttle plate as your restriction. If we have a really big throttle body, that throttle plate is going to be much less a restriction. So if we tip it open, we're going to get a lot more airflow into the engine at a very low throttle angle. Small throttle body, it's going to be more of a restriction. So we start to tip that throttle plate even further. We're going to need to have that much more throttle blade opening to get the same airflow come into engine. So hopefully it makes sense. So that's going to be kind of the idea behind this. This is what it's going to park itself at. Again, the spark time is going to adjust beyond this. So it's going to be adjusting the real-time torque output. This is going to fix to give us our base torque and our base airflow. Then we have our post-start position as well as our post-start RPM. This is going to spell out what we want our engine speed to go to when we're firing it off here. And we can see it's going up here at about 10 seconds. I'll leave these default values of where they're at. This is going to give us a little bit of a flare effect in the engine speed when we're cranking it. Then we have our post-start position. This is going to add to our idle actuator position table. This is going to be their throttle blade opening, so it's going to tell the throttle plate to open this much more for the first few seconds when the engine fires off. 10 seconds, I'm going to zero this out. I'll probably only say maybe 2% more throttle opening at 0 seconds. And then between these, I'll just allow that to dissipate. Click H. We'll close that throttle angle after the first few seconds of the engine running. We don't want it to get too high in idle speeds. Again, I have a pretty large throttle body, 82 mil throttle body for this 4-cylinder engine. So it's not an extreme size throttle body, but it shouldn't need very much throttle angle opening to make a pretty large difference in airflow and therefore engine torque, therefore engine idle RPM difference. Okay, so hopefully that makes sense of what all the settings mean and what we're doing with all of our settings in here. We'll have to see how this goes when we actually get it running. So Rev limiter, taking a look, we're going to leave it on ignition cut, 9,000 RPM, automatic legacy value, that should be fine. Keep that simple. Thermo fan, we have it set at 190-degree temperature, on-off control. It's by engine temperature, and it's going to be activated at 0, so it's going to be sending a low side out to the control. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.